Hello everyone. In the previous video, we learned average value and RMS value of a sine wave. In this video, we learned two new waveform constant, form factor and peak factor. Now summarize our average and RMS value for a sinusoidal wave. Average value is 0.637 of peak value, that is Vm, and RMS value is 0.707 Vm. First, we understand form factor. Form factor is the RMS value divided by average value. For a sinusoidal wave, the form factor is 1.11, and if you analyze the RMS value, that RMS value is 1.11 times average value. Now understand why form factor is important. Now consider two waveform of same average value. So let's consider a square waveform and a sinusoidal waveform. Here we assume the 10 volt voltage for both the waveform for the average value, and if you calculate the RMS value for the sinusoidal waveform, it is 1.11 times average value. For the square waveform, the RMS value is equals to average value. So if you calculate the RMS value of a sinusoidal wave, it is 11.1 volt, and for a square wave, it is 10 volt. As you know, the RMS value define the heating effect in the system. So if there is a more RMS value, that will provide more heating effect in the system. Every waveform have constant form factor, so it helps us to understand heating calculation in resistive load. As the form factor depends upon RMS value, so it indicates how effectively AC waveform delivers power compared to DC. So a waveform with a form factor closer to 1 delivers more uniform power. Form factor also used for instrument design, as many AC measuring instrument measures average value and assuming sinusoidal wave. So the meter calibrate to display RMS value assuming a sine wave. So if the wave is not sinusoidal, the reading become inaccurate. Form factor is used to check the quality of the waveform. As we know, every waveform have distinct form factor. For a sinusoidal wave, it is 1.11. So engineers use to analyze the waveform, it is sinusoidal, square or triangle with the help of form factor. Let's understand what is peak factor or crest factor. It is defined as the ratio of peak value to RMS value. For a sinusoidal waveform, the peak factor is calculated as 1.414. Now understand why peak factor is important. As the peak factor indicates higher peak, so for the insulation design, insulation must withstand the peak voltage, not the RMS value. As the peak factor depends upon peak value, so it helps to select a semiconductor device rating to keep the peak voltage stress. So higher the peak factor means higher the device stress. Waveform with sharp peaks can damage system. So deviation from expected peak factor indicates waveform distortion or harmonics, which affects the power quality of the system. Peak factor provides safety and reliability in a system, as the waveform with sharp peak can damage equipment even when the RMS current is moderate. As the peak factor analyzed to ensure the electrical equipment operates safely under transient condition and prevent overloading. Now summarize form factor and peak factor. Form factor indicates power and heating concept in a system, as the peak factor indicates maximum stress value for the system design.
Thank you for watching the concept. Please like and subscribe my channel.